All right, guys, how y'all doing? All right, guys, how y'all? And I'm not feeling that good today, so I'm just gonna cover one section. Um, let's do one hard logarithmic function. Let's say y equals e to the x natural log of x. What's the derivative of that? After that, we're gonna do inverse trig functions. That is something that you could just let me finish my lecture, and obviously, if I don't finish it, I'll give you extra day. And next week is the spring break. All right, we're gonna learn how to do the derivative of that, and then for the inverse trig functions, it's just literally using the inverse trig functions. Oh yeah, I'm gonna postpone the test. We're gonna do the inverse trig functions, the formula. We're not gonna do any crazy things about that. That's all. When will the exam be? No. Let me finish one more section. That's a hard section, and then I'll provide the password. All right, so let's look at this. Let me rewrite the problem like this way. So what's the derivative of f of x? So if we're doing the derivative of that, is just x to the natural log of x, and then we take the derivative of this x natural log of x. All right, and that's the one we need to look at. What's the derivative of that? 1 natural log of x plus x times 1 over x times 1. And we can simplify that. And you get e to the x natural log of x plus 1. Okay. That was a hard problem. Yes. Now let's look at the inverse trig functions. If you have the book, you could open the book. Derivative of inverse trig functions. We're literally using the formula. We're not going to do anything crazy. We're not going to do anything crazy. We're going to use the formula. I'll wait a bit for you guys to catch up. Oh, I didn't do inverse trig functions last week, so I'm going to extend that for tomorrow. Wow, I completely forgot the inverse trig functions. I'll give you extra day for derivative of log. And then related rate, I'll change it to Thursday. Where's the test? Did you guys get that stimulus yet? It's called stymie. All right. So let me do this. What's the derivative of sine inverse of u? You're going to learn that more in calculus 2, why this makes sense. It's just 1 over 1 minus u squared times du dx. So I take the derivative of u in respect to x, where absolute value is less than 1. You got a frog? Nice. Send me the email picture of your frog. The other one is, what's the derivative of tangent inverse of u? 1 plus u squared times du of x. I didn't even post the exam date. So initially I thought that I was going to do the exam this Wednesday. We just might have to do it on Friday. Or we'll just have it over the spring break. Derivative of secant inverse of u, 1 over u squared minus 1 times du of dx. Absolute value of u is 1. Derivative of cosine inverse of u, 1 minus u squared du of dx. This last part, don't worry about knowing that. It's restrictions, so this derivative work. Yes, exactly. You have this, all of them on the book. This is something that if you're in live class, I didn't have you memorize it. I would have you print it with you. And bring it into class during the exam. And u squared minus 1 du of dx. Now out of that, let's do an example problem. Secant inverse of 5x to the 4th. What's the derivative of that? Well, this is the u. So it goes 1 over absolute value of u. And then put u squared minus 1 times derivative of u, that would be 20x cubed. And we could kind of simplify that for x. So you end up getting just x, 25, x to the 8th minus 1. That's all. This is what this section is about. All right, I was going to give you a quiz, but I'm not feeling that good. My throat is swollen up. I don't know from what. Should have not gone out this weekend. Probably got the coronavirus 2.0. So if anybody gets sick, I blame it on coronavirus. Alrighty then. If you have any questions, see me right now. Sorry for ending it. I'm gonna spend more time on related rate. That's a really hard topic, and I need to make sure that we do this. Those are a lot of word problem, and that is something that I need to spend time on it. And no quiz today either. Okay. All right, guys. I'm gonna be live here. If you have any question.